So we're going to be doing this live. So this is my full webcam originally without it being flipped. I think we need to mess around with some settings here. I think we need to do that. So before we do, let's quickly link a few things to Discord so you guys have something to look at. Delete at everyone. Delete. Boom. You know, I used to have a button that brought me directly to Twitch, and I never updated it. All right, mute, low quality so I could see chat now. Hello, chat. Paste the Discord. Paste this in here. Enter, send. Okay, that's sent. Let me get, okay, hold on. Let me get my phone up now so I can see you guys. Okay, that's there. And then we're going to need a few other things. I'm going to need a YouTube channel. And then we're going to turn on music, and then we'll go over what's going on here. And then we're going to go over void pointers versus whatever. Oh my goodness. Oh. Void pointer versus standard any is what we're going to go over, but we'll go over that in a second. What music are we listening to today? We've done a lot of sessions. We haven't done sessions Diana in a while. Let's do sessions Diana. That's kind of fun. Restart. Play. And then, okay, audio looks good. Okay, hi there, Coder of Paradise. Hello, hello. So now we're going to be doing a little bit of color stuff. Should I be more saturated? I think I do. Is that too saturated now? I think it needed a little bit of saturation, because if we go down to 50, this is where we were at. I think a little, ooh, that's too much saturation. So that's too much saturation, right? I'm a little bit too glowy, but I do think it needs something. It does need a little bit of saturation, yeah. Also, ignore my computer. That's the RGB software hasn't been updated, so I'm too lazy to update it. So it's all like fucked up right now and like in its default, just color RGB state. God, I love my computer though. Water-cooled 4090. 14900K on a triple rad cooler. It's great. So the saturation needs to come down. So this was default. Too unsaturated, I think. It's too unsaturated, right? Let's go to like 60. That's too much contrast. It's so funny how like when you mess around with camera settings, it's like, oh yeah, I know a streamer that has high contrast. There's a lot of streamers who have high contrast. To me, I don't like how it makes my wrinkles look. So low contrast, cloudy AF, boy. I like 50. It looks fine. You can see the sweat and the wrinkles, but it's not overbearing. So let's try again, default saturation. Yeah, it's too grayscale, right? I think we need, oops, that was the wrong button. There we go. It's too grayscale, so I think we're gonna go up to, let's go 60 for now. I think that's good, right? Let's go with 60. And then, is it? Do I need volume in my hair? What the heck? I'm looking at like the flipped image of me and my hair looks fucking stupid. And then I look over here and it's like, well, that looks fine. But I don't know, it's because I'm so used to looking at the one over here. Oh shit. Oh God. Bad hair day. Oh no. Plus I'm sweating because it's so fucking hot today. Okay. So where do we go from here? We don't need compensation or exposure or anything. Actually, do I need exposure? No, we're center. We're center. Yeah, no, this is fine. White balance needs adjusted. So right now we're a little on the cooler side. So this is default. This is like auto white balanced. But if we turn it off, we go cool. Which I actually don't mind a little bit of turquoise in it because my model's turquoise, so it kind of like matches up, or teal. But if we go warmer, I mean, obviously we can live in the sun, which looking at this setting, I can tell you right now, at least one streamer who does this shit. Or we can live in like, it's like health bar, mana bar. There you go. Current automatic white balance probably sets it at like here. Oh, even cooler than that. Here? That's pretty close. Automatic version goes even cooler. God damn. I think we can afford to go a little bit. I don't know. Code Toil, hello, welcome to the Let's Change Camera Settings stream for a bit. Let's go a little bit warmer. Okay, you know what? Let's lower saturation and then cool down the temperature just a bit. Nah, it looks better automatic. I think the automatic white balance actually does a pretty good job, but I need more saturation. This is just, oh God, it's so unsaturated. I think this is better, right? This is default saturation. That's default. And then we increase it up to 60. That's the difference. I like the higher saturation one more. Maybe just a hair more contrast. Contrast looks good because it helps like define the black lines more. But I don't know how much I actually need it is the thing. Because I'm so well lit because I have the fucking Son of God in front of me. Just blinding me. That's how bright it is. It's just like one lamp shining me in the eye. I think we're good. Okay, let's go with default contrast. I just like the increased saturation probably more than anything. And then do we need to zoom or anything? No. Although I would like to point out this is a real zoom. If I do this, I can physically see the lens. I can physically see the lens like zooming in. So I can actually see the lens like zooming all the way in on the camera. Katie Bug! Listen. We had camera stuff. All right, zoom out. All right, we're good. Let's get back to what we always wanted to do, which is programming. All right, so here's the goal. What am I doing? I was changing camera settings so I look nice. I want to do IRL streaming a little more, but we needed to change things around a little, you know? I'd always come in at weird moments. I don't know how you do that, all right? What's the life of a streamer but making everybody laugh every 15 seconds, you know? So here's the plan, all right? This is what we need to do over the next 3 days. I have, excuse my language here, fuck all to do all weekend. And you know what? I'm caught up on essays for school and everything, all right? Fucking, I am ready for this weekend. Here's the goal, okay? Our goal is to have a working prototype with some art implemented. So if you guys don't know, we commissioned about $3,000 worth of art. It's beautiful and it's wonderful and it's everything I could have asked for, and it's perfect, right? It's wonderful. So we're gonna start implementing this. Now, how we're gonna do it is we're gonna have a game, and it's not the card game, it's a different kind of game, okay? We're doing the roguelike shooter thing, but it's not a shooter and it's like kind of a roguelike. You'll see it when we implement it. But in any case, I mean, not in a weird way, I don't think you've ever looked bad on stream. Oh, shut up, Katie Bug. We all look bad on stream. We're VTubers, okay? So our goal, okay. By Saturday evening, I want a working prototype of the game. I want something on the screen and I want something I can move, okay? I don't need like enemies. I don't need AI. I don't need damage or life values. I just need something I can move around on the screen and we can test how it feels to move and shoot. That's it, all right? We're doing Mario 64 prototype levels of prototype, okay? If movement doesn't feel good, the game doesn't feel good, my life doesn't feel good. So that's what we're gonna do, all right? Working prototype Saturday evening. Now, this is a new and different architecture than how we did our last 1.5 video game engines, right? ECS, Entity Component Systems. Very different, kind of based, but it does take a lot of effort to get it going. But now that we've kind of got, you know, a lot of the way there, the rest should fall into place, but I'm sure we're gonna hit a lot of roadblocks and everything, but we're gonna be, that's what this weekend's for, all right? Once we get the prototype going, it's gonna be, oh, It's gonna be smooth sailing, all right? Because of how entity component systems are designed, it's a lot of front-loaded work, all right, just to get things going. But after that, it's all smooth sailing, all right? It's gonna be nice. It's gonna be smooth as silk. And we get to start using this art for, you know, an actual video game and not just to look at. It's a lot of really nice art. I don't even have all of it downloaded. Look at this hot ass wolf. That's a hot wolf. I don't know what we're gonna use it for exactly in game, but it's cool. And then I have a bunch of just random things. Ew. Okay, this is a micro abomination, but do you think people are gonna make like inappropriate sexual jokes about it? There's no way, right? That won't happen. It's the internet. The internet wouldn't make a joke like that. The furries will shrimp. Heck yeah. Oh, my favorite art. Firefly Queen. Oh, what a great piece of art. Oh, man. Or I guess because we're not using this for elements of the game, Queen of the Fireflies. Queen of the Fireflies. Oh, man. What a great... No, I lied. This is not my favorite piece of art. This is my second or third favorite piece of art. My actual favorite piece of art where is it? There it is. Yeah, fireflies. Oh, this is my favorite. This is great. Look at those fireflies with cute little swords. Nah, yeah, people won't make jokes like that, right? No, this is great. I love this art. It's so good. This is from an actual concept artist in the industry. Space Cadet Aphrodite, also a VTuber. Well, recently a VTuber. She started streaming after I commissioned her. She's now a VTuber. And then, yeah, it's great. A lot of concept art done. Katie Bug, you have your 3D model coming soon, don't ya? And then we have this ugly ass fallen elf. Ugh, disgusting. But you gotta have your ugly creatures to have a pretty creature, you know? Oh, and all the nymphs. Oh, all the nymphs are done. Look at this. Oh, that's Shade Nymph. That's kind of ugly. I don't know, like Chaos Nymph? Oh, that's so pretty. Although, hold on. Hold on. Everybody's favorite is Life Nymph, right? Hold on, where is it? Well, Life Dragon. Oh, Life Nymph or Life Dragon? I feel like Life Dragon is everyone's favorite. Everyone seems to love Life Dragon's art. This is pretty good. This is a little good. Little perfect. Do you think the Chompy monster gives... Ew! Okay, next. I must steal them, Lamau, and use them in my bug army. Oh, they're so cute. Yeah, fireflies. So adorable. Anyway, we have all the art commissioned. All the art is done. So glad I commissioned her for creatures and not buildings or shields or weapons or anything. Because Elements the card game is a nice tribute, but I'm glad I made creatures because now I can utilize them for this game. The whole point, like, I don't know. It's just, it works out really well. Look at how creepy this Zora ass freaking Mind Flayer is. Plan to re-debut in late September or early Oct. Ooh, exciting. Exciting, exciting. All right. Let's get to the actual program and talk for a bit about programming. So I'm going to use some complicated terms here. If you don't know anything about programming, bear with me. This is all getting deleted. This is all getting deleted. I was just messing around before with like vector pairs and everything. Okay, so this was our problem, right? Let's break out Paint. Let me show you my problem that I've experienced over the last 2 days that I have largely solved now, I think. We have to implement it, but I think I solved our problem. This is our problem, okay? In this game, we have entities. My computer is lagging and I don't know why. So if you see frame drops, I apologize. Why is my computer lagging? It's like taking a hit. What the heck? Oh, my CPU is burning up too. Okay, hold on. Hold on. Where's my performance? Ooh, something is hammering my cores. What the heck? Open resource monitor. All right, what's giving me the hit? calculator app. No. VTube Studio. CPU. All right, what's CPU? What's taking search indexer, average, camera hub. Oh, is it my camera? Oh my God, my camera is destroying. Actually, it's not really that. I wonder if it's hot just because my room is hot. My CPU is like really hot right now. Hold on. I have a way of Fury. Hold on. Fury control. That's my RGB. Right, wrong one. Fuck. What's the name of my RGB? What is the name of my system? Kingston? Oh, come on. You boot up on thing every time. Ugh. Dude, you boot up every time I start my computer and I exit out of you, but now you want to hide yourself? Ugh. Hold on. It's actually kind of important now. We're really getting hit. 1 second. What is the name of the thing I'm thinking of? Oh no. Oh no. Where is it? I thought it was Kingston Fury. CPUs idle 100, 140 degrees Fahrenheit safely. I wouldn't touch it. Yeah, there's idling hot, and then there's like rendering lag on the stream on a 60 FPS stream for a 14900K hot. It's just, it's weird. It shouldn't be that hot. My GPU is like silent cool. Anyway, let's get back to it. Let's just ignore that for a second, I guess. All right. So in C++, okay, what is our problem here? So we have an entity. Anything in the game can be an entity. The main menu can be an, oh, look at this lag. There we go. Jesus. It's like, I can feel the lag. Everything in the game is an entity, okay? The main menu is an entity. The character is an entity. A bullet is an entity. The music is an entity. If it exists in the game space, it's an entity, okay? If you go to Task Manager, there's a tab to see your apps who start with computer. Darian. If you go to Task Manager, there's a tab to see your apps that start with computer. App history. MSI Center? No. CPU time 3 hours 15 minutes. What the fuck is that? A new update is available. Skip. What is MSI Center? Oh shit. Let's build your own MSI Center. Fuck you! I don't know what's hammering my computer right now. It might just be my webcam, but that's so weird. It wouldn't do that, right? Master Plus app. That's what it was called. Okay, what's my CPU temperatures? This keeps track of it. Hello? Startup, the startup tab. Oh, based. Cooler Master. Hell yeah. All right, what do we got going here? Oops. Let's see. CPU is 56 degrees Celsius. Well, I'm not gonna say resting. We are doing a lot with it right now, but okay. That's kind of hot though, isn't it? Why does my cooler feel so hot then? I'm like feeling the top of my computer right now. That shouldn't be that hot though, right? Well, maybe everything is fine. Also, let me just fix my lighting on my computer real quick. Hold on. Okay. So this is my computer right now. I need to fix the lighting. So we're going to do this together, okay? We're going to play. Oh my God, I really can't make this any tinier. Oh God. So we're going to play Let's Fix the Lighting, okay? It crashed. Oh my God. RGB is hard. Okay, never mind. RGB stays fucked up. All right. All right, let's get back to this. All right, programming. Stop distracting me, okay? So in this game, we have entities. Everything in the game, music, art, sprites, if we have any, animations, player characters, bullets, enemies, UI, right? Everything is an entity, okay? More or less. Now here's the problem with entities, okay? In object-oriented programming, which this is not, in object-oriented programming, you have your like main object entity or whatever, and then you split it off, and like this is the player character, this is an enemy, this is the whatever platform, right? You split it off in a million different ways. In ECS, everything is an entity that can have what's called a component, right? You can have many components for any given entity. Entities, in fact, as far as objects are concerned in the program, the only thing they have is a unique ID number. That's it. And well, it's for a variety of reasons, but every entity has a unique ID number. And I'm not even talking about like class Fireball has an ID. I mean, like every individual instance of a Fireball is going to have its own unique ID number, and that's really important. For instance, what if you design your game in a way where like you throw out 2 Fireballs of, that's not a good one. Let's say you throw out a really big Fireball, a single really big Fireball, okay? When you check for collision with any other entity on the screen that is able to be collided with, how do you tell the program like, hey, yes, Fireball can collide with things, but don't collide with itself? That's what the unique ID is for. If the ID matches, it knows, okay, it is myself, so I'm not going to execute successfully, right? It's one of those things we can check against to make sure we don't like hurt ourselves. Like if player casts big Fireball, it's like, okay, well, player casted it, therefore any instance of the skill hitting something that is the player that casted it, ignore it, right? It's another thing we can check against. So that's important. Then every entity then has components, and that's really all an entity is. There's no methods, right? Because we're not object-oriented programming. There's no method here of like, wow, that's how much I'm lagging. There's no method here of like, you know, take damage function, right? That doesn't exist. In fact, the only thing we're gonna have with an entity is just add component and remove component, and that's it. Those are the only things we're gonna have when it comes to any individual entity. Now here's the hard part, okay? Components, as you can see in our kind of trivial setup here, components can be literally anything. Hold on, let me make this easier for you to see here. Components can be literally anything. They could be a floating point value, they could be a color value, they could be a float, they could be a Boolean. It doesn't matter. They're just very small individual like data values to put onto an array, okay? So how do you well, not give, but how do you store components in an entity, right? It's the big problem we were kind of solving. So I did a bunch of research and I think I figured this out, and it's going to be complicated. So you guys got to go on this journey with me. Okay. Are you guys ready? Cause we're going to hear a lot of C++ terms you may have never heard before. Okay. Cause I went to Narnia, bitch. Okay. And I saw things that you should never see. Okay. Let's hear what happened. Okay. This is what we're going to do. These individual components, right, in our program, every component is going to have a vector associated with it of that type. This vector can go on forever or however much we need, okay? These vectors contain every instance of that component on every entity in the entire program, okay? That means if there's a component for, say, position value, so every single entity that needs a position value, like the UI or the player or the user mouse or something like that, the little mouse thing in the game, everything is gonna need a point value to know where everything is relative to that point, right? This point value does not apply to stuff like music. So that's why this component wouldn't just go to everything. When an entity gets created, what's going to happen is that entity will have a pointer that points to that spot in the vector, wherever it is, right? We're going to use the term index a lot, but we're not quite to that level yet. But rather, in this entity, it's going to have some way to pointer value to any instance of that component in the vector, right? Or that vector of that component, if it has that component, right? So that add component function we were talking about, that method, the only two methods we're going to have in every entity in the game, add and remove, right? When it adds the component to the entity, what it's really doing is adding something to this vector. It's pushing back, so it's adding an element to the end, and it's going to give you a pointer that's associated with that entity that says, hey, whenever you want to reference this position value of this entity, you're going to have to get the data from this point on the vector of that component, right? Okay, what are the advantages of this? First, before we even continue about how we're going to implement this, right? What's the value of this? Well, the value is systems. So any system in the game that needs to reference every position value of every entity because it cares about that, like, let's say we have like a physics system, right? Well, if an entity has affected by physics or can have gravity or whatever qualifier we want, if that's successful, then the system goes, okay, well, I'm going to iterate through every entity and do something to it. Well, the advantage of this is it actually saves the CPU some time. It's a better way of architecturing our game, right? Because what that system will do is just iterate through this vector. And a vector is just an array that's dynamically allocated, so it just reserves more memory as it needs it. So what it'll do is it'll sequentially in memory go through every single point in that vector, and it'll go, oh, okay, so that's what I need. Rather than having it, the weakness of object-oriented programming, if you don't know what you're doing, is it'll jump around to different spots in the memory just to get things like iterated through. And this is a more cleaner way of setting it up. Now, object-oriented programming has already known this for a while, okay? This isn't unique. But ECS, you kind of have to do it, so it just kind of works out really well. Okay, but we're not done. It's one thing to have a referenced value to another container, right? The problem is how do you dynamically store a bunch of pointers that reference different values across the program? You guys see the problem here, right? You can't have a vector with more than one data type. It either has to be all integers, all float point values, whatever, right? All colors. It needs to be whatever type T is, it's only that type forever, right? Now that's fine if all we have are like float point values or if it's like a position value, right? The problem is we don't just have that. We actually have a lot of values. We have floats and damage values and bools and all that shit. So how do we store a bunch of pointers that represents the data from these components that an entity has? Well, you can't have a union of types. Variant? Oh, people are naming stuff that we're not going to use. So yes, there are a lot of options for this. This is a problem that has been approached many, many times in programming. What we're going to ultimately come down to is we're not actually going to use this, but it's ultimately our answer. Vector void pointer. Now, we're not actually going to do this, but it's kind of our answer to what our issue is. So you could have a class with methods to get the stuff inside. No need. Well, maybe we have to just incidentally. I'm not planning on it. I would imagine it would just be like the private, just get, whatever. Anyway, we're gonna have a vector void pointer. So what is a void pointer? What does that mean? Now, we're not actually gonna do this, but it's a step to what we're gonna use, which is a term I didn't even know existed until like 2 days ago, okay? Believe it or not. A void pointer is code smell. Is that a better way to, is that a good way to phrase that? It's code smell. You shouldn't be using void pointers, right? Void pointers are unsafe, but not terribly complicated. So here's the thing. It does solve our problem, right? This is a container this entity can use as a way to store all of the pointers to these different components. Oh, there's lag. Different like vectors, different values. I could store a bunch of stuff, right? This is just a list of pointers, right? Now, what's the problem with this? The problem is it can't be dereferenced. Not in C++. In C, it can be dereferenced. I think in C++, it's undefined behavior, which makes sense. What do I mean by that? What I mean is that when you reference a void pointer, all you're pointing to is just a space in memory, okay? The actual void pointer, whatever you call it, PTR, whatever, right? It's a void pointer. That void pointer can indeed point to a space in memory, but it doesn't know what it is, right? It doesn't know it's a float point value or an integer, right? Now, in C, you could static cast it to an integer and kind of make it an integer because you know it should be an integer. But in C++, I think you actually get errors if you do that. If you can, I think it's undefined behavior anyway. Now, but it does solve our problem, right? That is what we want, but we want that referenced value. Now, C++ happens to have a feature that came out in C++, I'm gonna say 17 or 20. Standard any, which as far as I can tell, a standard any is just a void pointer, but it does a lot of really cool things. So a standard any can also do what a void pointer does. It can point to any referenced value you could give it, integer, float, it doesn't matter, right? It does solve that problem. And it even keeps its referenced value. There's actually functions you can call on the class object standard any that actually gets, I think it's any cast, whatever it is. You can get the referenced value of what it is, which is really important, and it defines the behavior, so it's not undefined behavior anymore. I think we're gonna use a standard any. Now there are other things. 17, I was definitely using it before 20. Yeah. So there are other things we can use. There are variants, there are unions, but I think in our super specific use case, we're using a standard any. Now, why do I say our specific use case? The reason why we should use an any is because we are implementing ECS, but we're not quite doing it the same as everyone else. We are going, I think I'm gonna go in, I don't even know if we need to do this. I think I wanna go in with the goal that we only have one entity for every thing in the game. Music, animation, player, enemy. It's all going to be this one class of entity with its own unique ID number, and then anything can have any component in the entire game. I think that's what we're going to go for. That's our goal. Now, in order to accomplish that, we need some way of giving any object in the game, any value in the game, some component and the ability to remove some component. And I don't know how else we would do that besides standard any. There are other ways to store these values, and I think if I did it more correctly, I would use like standard variant. But I think standard any's are really only choice here in terms of like our specific use case. What else do I need to say? Is there anything else? We're gonna have a vector of entities, but I think that's kind of above this level. Standard any that stores any pointer value to any component that it gives to. And then when we remove the component from an entity, when we remove a component from the entity, we then take it off of this vector and off of this vector. And then we can add or remove components at will. I'm trying to think of the downsides of this. I think this is about as well as we can do, right? I'm trying to think of what other methods we need to call an entity besides add component and remove component. Because if we need to change any values, those are systems, right? Oh. How would systems access the pointer values there? Oh. Ooh. Oh, I have a question. Is that not good programming? What I'm thinking is that if this is a private, whatever, if this is private, this pointer vector to all of the component values for the entity, is it bad if we need to change those entity values if we actually change it in the vector those pointers are pointing to? Because we would iterate through this. What we would do is we would have our entity, and then we would iterate through all of its pointers. How would we iterate through this? I'm thinking how we're going to decide the difference between private and public here. This has to be private, right? There's no shot this is ever going to be public. So we have add component and remove component. Is there anything else we're going to need to have access to? We need to have access to the values, right? If a system's like do damage to entity, how do we grab the health value, that integer, from that entity value? Well, that system would have to iterate through every entity that has taken damage that frame. Entity has taken damage. Okay, system activates. Okay, iterate through all entities that have taken damage. When they take damage, get their health value. Would it get its health value by finding the iterating through entities and then grabbing that entity? It's like, okay, give me your health. Or do I iterate through the component that's like, this is the health component? But I guess there would be a pointer to that value, right? So it would be through the entity. Get component of type function. Oh, that is true, huh? Well, in any case, we're going to worry about it later. This is what we're going to do. Any complaints before we actually program this out in C++? Now, you're going to see a lot of goofy shit here because I did stuff off stream. We're going to delete a lot of it. So, what are we going to delete here? Oh, so we need to bring up my little image here. Boom. Boom. Zoom in. Scroll left. Move it over here. Ooh, wait, move it way left. Holy shit. Hold on. Hold on. Ugh, whatever, it works. Okay, so let's change around a few things here. There we go. Okay, beautiful. Usually with systems, you iterate over the components of a specific type. Ooh. Well, if that's the case, how would you know if you have an entity player, right? And then you have a component that player entity is pointing to in that vector to know what its health is as like a, I'm going to say index, but I don't know how accurate it is to call it that. Indexed value of what the health player should be. The system's not going to iterate through the entity values. It's going to iterate through the component values, which makes sense to an extent, but how does it know it reached the index player value? How does it know that? Because the component vector itself doesn't actually know what entity stores what information. It's just a container for that information, right? The entity itself has pointers to those values. But how does the system know, just by scanning over the component vector, who owns that value? I don't think it can. I think you have to go over the entity's pointer values, right? Huh, I haven't really thought about that. We'll go over it anywhere. Or that's a later thing anyway. We're not even to systems yet. That's gonna be like a tomorrow thing probably. But in any case, we're gonna delete. Oh yeah, I tried messing around with like standard pair, floating point values, shit. That's dumb. Don't do this. Okay, ignore the data. Do I need an entity manager? Fuck no, I don't. Sorry, I was also messing around with the switch case. I was like, this is stupid. This is dumb. I shouldn't be doing this. Okay, keep that add component though, because we're gonna need it. Copy. B, delete, delete, delete. Okay, this add component, by the way, this function here is what we're going to be, what I want it to look like. I want add component player, and then the kind of component integer, which the integer is just an enumerator. That's all it is. So if I want like player health, right? Or, well, what's a good one here? Let's say we want player to now do damage type water. So what we would do is damage type water. Okay, player damage type water added component. That's what I want. So like add component fucking Meat Man 2 enemy, right? Is controllable. So now it's controllable, right? I want the most modular game that has ever been modulated, all right? Okay. So what are we gonna go over here? Right, the bit set. Okay. Here's the other problem. That's not a problem. Actually, hold on. I gotta Control Z some of this. How are we gonna have... What I'm thinking is that... Oh, shit. How does an entity know it has a component value? The answer is it doesn't, not directly. I think what I planned to do, the reason why I even had this here is because I have a constant number of components possible in the entire game, right? Currently 13, so 12 plus 1, right? 13 components. So what I did was I had a bit set containing the length of this number of components, calling it M components, right? So the idea is that when you add a component, because we have that enumerated value, is that this component is also gonna be something that's deleted here, is that you're gonna go to that value of the bit set and then you're gonna change it, right? So it would look something like, M components, bracket component dot, we'll say flip, but I know that's not the correct one. And then, yeah, perfect, right? Actually, I don't know the syntax for bit sets that well. I don't think it's dot flip. It might be, yeah, no, this is wrong. It's flip component. That's what it is. So that's what I would do. Obviously, there's no error checking here. You don't want to add a component and only to remove it, right? That's what a flip does. But that's kind of the idea. You can do some template program, and then that way, if systems ever want to check if any given entity has a value or not, it just has to go through like a 50 length bit set, and that's it. Which I can't imagine it being smaller than that. You can do some template programming to map the bit order to the component, like first bit is C transform component. You can do that. You can do template programming to map the bit order to the component, like the first bit is C transform. You can do that? I mean, I already have an enumerated list. And then when the player, or when the programmer, I guess, was like, okay, I have entity, whatever, integer, like, okay, this is just the enumerated value. So position, right? So flip components, flip position, and then that is just associated with that bit set. Is there anything different than what I implemented is what you're talking about? Like, I guess I'm not using templates, so it's not exactly one for one. Unless you're saying the existence of a pointer in our vector. Standard vector. Why do I still have friend entity manager? Get out of there. So standard vector, standard any, M. We should call this has components. Has component. That's a better name for it. M components. Okay. Then this is M has component. There, something like that. That should be fine, right? Never mind, seems fine. This way also works. Yeah. Okay, you said that in a way where it's like, I mean, it works. Listen, I know I'm not a senior fucking engineer. Okay, I get it. I'm the new kid on the block, all right? I'm the guy who does like the boilerplate programming and still fucks it up. But you know, if you got a problem. Also, what's up? How are you doing, man? Did everyone have a good 4th of July? I took yesterday off stream because I had to do more homework, but oh my God, chat, I had to write, I have a test. I have my first test, I think on Monday. I have my first test and it's like, it's supposed to be a 30-minute test. I'm just going to take it immediately after work because I can like study for 3 hours before I even start at the end of my day because I don't do fuck all at work. So I can study for like 3 hours. I have a test and it's about, what is it about? It's about, logic gates is next week. Monday's test is about, number conversions. So it's like octal to hexadecimal or hexadecimal to binary. And then after that, it's, it's something. There's something else associated with it I should remember, but it's the lesson. Oh, ASCII stuff. So like, what is ASCII? Like, what's the difference between ASCII and the other thing that like really on the metal programming people use because it's not ASCII? What's the difference? What does it stand for? The stuff like that. Oh, I loved this kind of stuff. Darian, I hope you're doing well, Darian. I hope you're doing good. I hear the, oh no, I'm sorry. You're not the one having the kid. Oh shit. No, that's, oh my God. It's been a while since I've even seen him in chat now because I do programming. He doesn't give a shit about programming. Fuck. I should know his name. He's the fucking Path of Exile guy. Oh God. Verisi. Oh, Fonzie. Like I would forever forget his name. He's the one having the kid. I think I only used that stuff in that type of... Darian, I know who you are, by the way. You're like one of my longest time viewers. I think I only use that stuff in that type of class. Yeah. I mean, it's good to know, right? If you ever get into like, I don't know, like Super Nintendo emulation, you need to know what hexadecimal is. It's like how the whole fucking console worked. I don't know why it's all hexadecimal, but holy shit. Why does it look like I have a black eye? Chad, am I ugly? What, am I gonna fucking... I look like I have the fucking plague. God damn. Jesus Christ. Why does Asmongold look so good on stream and my dumbass can't even fucking look straight without looking got like beat up before I started stream? Jesus. I need to lose weight. That's what this eye is telling me. I'm a fat fuck. That's what I am. Okay, anyway, stop distracting me, chat. All right. So, we now have our vector any. So first, we need to give every struct, every component its own vector. Now, the way I think I'm gonna do this is I'm gonna have a namespace data. And data is gonna have a component vector, or a vector for every component in the whole program. So we're gonna have standard vector C position, C or positions, call it something like that. And that way, that's our vector, right? Is that allowed? I don't know, but we're gonna do it. Is this a wise thing to do though? I mean, this is what the vector's gonna look like. I just don't know if I'm gonna put it in just a namespace. So now if I want to add a component, so it's like data, positions, bracket, MID, and then dot pushback, value, 0. What's wrong here? C position has no member pushback. Positions. Wait, am I missing something? This is referencing the vector, right? Data, positions, spot MID, dot pushback. Wait, am I dumb? Point? No, I don't want this. I want, wait, am I dumb? Positions is a vector. Oh, I'm referencing a specific value. Oh, dot point is equal to 0. But we need to push back first, right? So data, positions. Oh, shit. I'm doing this wrong. Because how do I tell the vector what size it is? I mean, it's a dynamically allocated vector, right? But if the first ID I add to a component is like 5,000, I have to give this 5,000 length vector, right? So if I have what's like a big value here? 16 bytes, 16 bytes, 4 bytes, 8 bytes. Well, I guess these are pretty small, damn. So let's say we have 16 bytes, right? So 16 times 5,000 is how much? $80,000 bytes or 80 kilobytes. Oh, it's pretty small. That's not that much memory. I mean, it's going to take more than that because it's a vector and it's dynamically allocated. So it always gives a little more space in case it needs it. But 80,000 bytes is fine. That's 80 kilobytes. That's fine. That's like, it's like one picture. It's not insignificant, but it's there. And to be fair, if we have any other values we need to store there of different entity numbers, anything up to 5,000 is free, quote unquote. To Bread, hi Gary. Hello there. How's it going? Hi. So what's wrong here? Expecting a semicolon. Okay, you still expecting a semicolon? F point int does not match because argument doesn't match parameter. Oh, these are float point values. 0.0, 0.0. You still accept ints? Okay, sweet. Okay. Now, here's the problem. This needs to be generic. This needs, I don't know if can you template something inside of a function? I actually don't know. I know you can template functions. I'm just wondering, maybe this is like a switch statement where depending on the switch statement is what entity data we add it to. Oh shit, are we bringing back the switch statement? So it would be something like, well, how about this? Before we do that, if component is less than 0 or component is greater than equal to greater than number of components, which I should have access. Oh, data namespace. Or what other error report would there be? Entity. Oh shit. Well, we would have to check if the component is already oh, I guess we would reference that bit set, huh? Or standard. Oh, not that. M has component dot value. Is test? No, it's not test, right? Flip, none, size, test, reset, set. How do I just get the value of a bit set value? Is it just test? Count? How do I grab the value of a bit set? Oh my god, am I having a mind fart? I don't remember. Hi, Gary. Tubred. Sorry, I saw your comment a while ago, like mentally. I don't know why I didn't say hi. Hi. Standard bit set get value. All right, what am I missing here? Count. Checks if all, any, or none of the bits are set to true. Counts the number of bits set to true. Compares the contents. Yeah. Equals, but I want to see if oh no, that is what I need. Okay, never mind, I'm dumb. So bracket component is equal to true, then there we go. Okay, hold on, this is confusing. There we go. If any of those are the condition, then return, return, right? And then end. Okay, so that's our error checking. If you entered in a component that doesn't actually exist on the integer list of components, because it's an integer, right? It's an enumerated value. If you return like 14 and we have 13 components, this will return nothing. If it already has the component, return nothing. That's all it does. It's just like, okay, check this bit set value. Oh, it's true. Okay, get out of the function. That's all it needs to be. Do I need to return a message or anything? Not now, but we just needed some basic error checking. It's still not enough, right? We still have to confirm like this entity, but you know, I think this is fine for now. What else are we doing? We need to flip the component. I can zoom in a bit for you guys. So, then we then flip the component. That just is true. So let's do that at the end. And then we'll just return. I could do a standard expected. Oh no, that'd be dumb. If we're doing a void function, there's no point in a standard expected, right? So what we have to do is we have to get standard any m components. So we need a pushback to a pointer value there. So before we do the pushback, we have to do, this is how I mentally do things now. If I know I have something to do, I'll just leave a blank space there. And it's like, oh, what was I supposed to do? Because I don't have to waste time commenting it in my head, which we're gonna do right. I'm in the zone, chat. And then I just order things I need to do. So now I know I have one thing to do. But is balanced check. What? I know you're talking about this, but what? So we need to not push back. We need to add things to this vector first. Then we're gonna make a pointer to that value. That pointer is gonna get added to this vector by pushing it back. And we're doing the referenced value, so it's gonna stay in scope. Okay, Jesus. Okay, let me think. We need to push back on the data vector first. So data, positions. We don't need to push back, but we do need to specify bracket component. So that spot, we'll say dot point for now, is equal to 0, 0. Now I know this is super specific, but bear with me a second. So that spot for the component value. No, that's wrong. This is not the component value. This is the MID value for this entity, which is, well, right now 0, but it'll increase every time we add an entity. What it'll do is we'll probably have an entity manager that will make entities for us, and it will increase this number every time we do it. Imagine the panic if you had 50 blank lines. Yeah, well, then you should start commenting. Gotcha. Okay, so we now have a point value at this point. So now we need to make a pointer to that. So standard Annie, and we're gonna call this pointer. This is a void pointer, right? Standard any pointer is equal to this value, or the referenced value of this. I think this is how you do it, right? Should I wrap this? Does a standard any need to be wrapped in a shared pointer? Remember that pointers can get invalidated if a vector is resized. What? Pointers can get invalidated if a vector is resized. What? Why? A vector resizing doesn't change its location. Oh my God. I see what you're saying. Are you telling me that in C++, in order to make room for some dynamically sized vectors, it has to move the whole fucking vector? Does it actually do that? Okay. So you're telling me that the best course of action for us is to make these arrays. That's what you're telling me. I could do that. I just have to make it an array and then specify the size, which I guess we could cap it out at like 10,000 positions or something like that, or 10,000 entities. Linked list time? Fuck you, we're doing a linked list. Although, no, it's bad. It's bad because we're iterating through the components. If we didn't have to iterate through these component vectors, or arrays, I guess, if we didn't have to iterate through these, then a linked list, unironically, probably wouldn't be that bad. But in this case, we kind of do. We need these to be in one memory. A standard list or standard map doesn't invalidate pointers. So a standard map, though, well, you have two problems, right? So a standard list is just a glorified linked list, right? But the problem with that is while it does even provide pointer values for you, we have to iterate through it, right? A map has the same problem. It's good for just storing information, but we have to iterate through these values. Lists are good for iterating, but not for random access. Wait, I thought lists... What? Why can't you iterate through a linked list? I mean, you can. Wait, am I dumb? I thought a linked list couldn't be iterated through very easily because you had to jump around in memory in just random places. Because it's not like an array where you have one block of memory where it's sequentially ordered, so the CPU doesn't need to move around that much in memory. But does a linked list, I know what a linked list is. It's a pair of values where you have the value of that element and a pointer to the next value of the element. But it's fine to iterate through them. If there was like 5,000 elements on a list, it wouldn't be an issue. You could just store indexes and then a vector growing doesn't matter anyway. If you just store indexes. So use a standard map, right? That's index. I mean, the whole point of this is to like store values for an entity in a way that it's easy to iterate through. That's the point of this. Oops. You just store indexes and then a vector growing doesn't matter anyway. So we can't use vectors. I mean, I'm okay with doing an array for different like position values, and as we kind of play the game, we know if we need to increase or decrease this number, right? So we could just have error reporting where we can just crash the game if we ever try to access memory outside of this array. We could just make it that way, and I know like, oh, bug report, array bounds exceeded fucking this is the array, right? We could do that and then just increase the array size as we kind of develop things. I could even have a warning where it's like, well, no. What the thing is it's not like we're storing 10,000 position values. It's more like if we have 9,000 entities and we make an entity for like a bullet in the moment, right? Because we are creating things as they go out because they have unique ID numbers, right? If that's the case, then the 9,500 projectile or whatever that has the one thing that needs one component, like play fireball sound effect, right? That's going to have its own entity, right? A sound effect. If that's the case, then this number on the vector would be like 9,800 or something, in which case this does need to be 10,000 elements long. That's why the number needs to be so high. One implementation of an EZS storage system is to use vectors once stores indexes to other vectors. The problem is that's what I'm trying to do, but you can't store. The whole point of pointing to a value on these vectors is explicitly to index things, but I can't use vectors. So is there a way to just tell C++ not to relocate a vector? Vector not movable or something? There must be a way. So do you have spares vector, which could have gaps in it based on the ID of the entity? So you have a spares vector, which could have gaps in it based on the ID of the entity, and a packed vector, which stores the actual data, which has no gaps in it. Oh God, these programming concepts are fucking above me. Okay, so you're saying I should have a sparse vector, whose purpose is explicitly to store the ID values of whatever entities are trying to access it, and then another vector that actually holds the data. Oh my God, this is a much better way of programming. Oh God, oh Jesus, I know what you're saying. I'm just trying to think of how to implement that. Hold on, we actually have to talk about this now because we're doing this exact thing in this vector at this very second, okay? So let's think about this. If we have a sparse vector that can contain any ID up to 50,000, right? A ridiculously big number, right? We're not actually reserving memory on our computer for 50,000 16-bit values, right? That's stupid. What we are gonna do is we're gonna have a vector that can take in a 50,000 unique ID value, whatever it is, and then somehow get that information to another vector whose job it is to actually store the value, probably via like a pushback function, right? And it would be like dense. So if you have 3 IDs that are like 2,000, 8,000, 40,000, right? And there's only 3 entities with those IDs that need to store functions, right? Or store values, index values, whatever. It's gonna go to the sparse, and then the sparse will tell another vector, the dense vector, what that information is, and that vector is only gonna be 3 elements long. By index, I think they mean an array index, aka a size t integer. Don't you need to allocate the whole block of memory all at once in array? Yes. But I've never done this before. I've never done like a sparse vector and like a dense vector that actually holds the information. So what I'm racking my brain on right now is how to actually implement that. So whenever you add a component, all you have to do is just just tell the sparse vector, hey, I want to store this information. That's all this would care about, right? And then somewhere else you would have the vector that's sparse. Maybe we would have like a class object. Oh God, we're object-oriented programming. Maybe we would have like a class object that would handle the logic for like data handling, right? Is there a way to avoid that without just making a class and doing all that shit there? I don't think you can. I mean, maybe there's some abstract way of doing it, but this feels like I just need to make like a module for data handling. Maybe not a whole module, but maybe like some sort of data handling object where all we have to do is just handle data dot, give it data, and it just does the rest. Greetings, Schoolboy Gary. What's up? Sorry, I've been kind of scarce lately. Work has ramped up for yesterday and the weekend. Ah, you're a 4th of July and weekend retail worker if I've ever seen one. Listen, man, we've all been there. We've all had to deal with the next day holiday returns. The fucking, did I forget to pick up my prescription? We've all been there. Listen, I worked a drive-thru. I know what it's like to get 20 discount cards from a patient who's like, give me whatever's cheapest, and then you only run like 2 cards because you're lazy and you need to get things done. Oh yeah, we've all worked retail, baby. I worked in a pharmacy. I have an implementation, but it's old and definitely needs a rework. Well, let me ask you this. You guys have seen my current level of programming, right? Which is not that good. Sorry, that was a bad effect. Not that good. There we go. Do you guys think I could do that? Well, I kind of have to do it, right? So what would it go into it? It would be a data handling object. It would take in, oh God, how the fuck would you arrange this? The component vectors would indeed be vectors. They would be C position and they would be positions, but this is only going to end up being like 3 elements long. That's all this is going to be, or whatever it is. However many, every entity that has a position, it's going to be X values long, right? However much X is, which is a much better implementation. Wait, stuff them in a standard map and worry about it later if it gets slow. Sure, but like, why not do it now? Like, why not? Listen, chat, all right? Spoiler alert, this is not going to be game of the year. It's also a learning thing for me. So if we're going to learn, like, let's not get lazy about it. If I wanted to be lazy, I would just use Game Maker, you know? We're doing C++. We like the verbose here. We like verbosity. We like blowing that standard dick, baby. ECSs are complicated to get right. Yeah, but like once we get it right, oh baby, it's beautiful. With a standard map int object A, you can do A 1, 2, 3, 4 and it magically gets allocated. Yes. The problem with that though is when you say worry about it when it gets slow, that's kind of like a problem, right? Like, well, though, to be fair, it is going to be a 2D game, but I would just mentally be prepared for like, okay, it's a 2D game. We're also going to have 10,000 objects on the screen. So if whatever a standard map implementation can handle, a 10,000 object thing where 10,000 entities are doing different things all at once, if it can do that, that's great. I'm just worried that it's not going to be able to do that very easily. Actually, no, it can. It's a 2D game, right? Our bullet hell shooter handled 10,000 objects trivially. Maybe not trivially. Maybe not trivially. It kind of fucked up. It kind of fucked shit up. That's true. How often do you need to iterate it? Walking a binary tree isn't too bad, or just copy it into a vector once per frame. If a standard map contained all of the component values for all entities in the entire thing, we'll say 10,000 entities, because that's not unreasonable for what we're going to be doing. How many times will we need to iterate it? It depends on the amount of systems. If we have like 1, 2, 3, I mean, off the top of my head, we're going to have at least 8 systems every single frame. So 8 times at a minimum. Although to be fair, not every system is going to iterate through the entire map, right? You might have some systems that only iterate through a fraction of it because of whatever entity qualifies to be iterated through. Because, well, I guess you could make it where you iterate through components, where like if a component, or if you iterate through entities. So like if an entity got damaged, we could push back on like damaged entities vector for the frame. So it knows to like play the damage sound, play the damage value on these entities in that vector. The problem with that is that in order to get it onto a vector, it's going to be a lot of copying. That's my problem with it. Although, to be fair, entities themselves are pretty small. Like all in all, right? You have a bit set that may contain 200 bits, whoop-de-doo. You then have a standard string of some kind of tag, a Boolean value, to be cold or not, and then an ID value, like an integer. And then a vector containing a bunch of standard any pointers. How big is a standard any object? 64 bytes! What the fuck? Oh God. You know what? I know exactly why that's so big too, because it's a void. How big is a void pointer? It's like nothing, right? Oh God, it doesn't even know. Oh yeah, I guess it wouldn't know, would it? Oh yeah, I guess a void pointer doesn't know what it is until it is that thing, huh? You got at least 50 gigabytes of memory bandwidth on a PC in the last 10 years? Chat, can I tell you a bit about my pet peeve? Can I tell you my biggest problem with the video game industry today? I'm not gonna complain about the Call of Duties of the world, okay? You know what? Fine, take 500 gigabytes to make your one fucking video game, okay? My pet peeve is when small 2D games take a way unnecessary amount of resources to run, okay? Listen, I love Slay the Spire as much as the next guy, okay? That shit isn't free to run. Have you guys seen the resource requirements? Not on Steam, but like in practice, Slay the Spire. Like, it's not a cheap game to run, okay? They know what they're doing too. I don't know, my pet peeve. I feel like that game could be made significantly more efficient. Am I the only one who like starts a program and it's like, wow, this takes so little resources, I'm just gonna keep it on. I do that shit all the time. Hell, some of my RGB software, I just always keep running because it's so little, it's so insignificant that I don't care. I don't know, I can't be the only one, right? I feel like there's value in having like a program that takes so little. Like, think about the giant fucking dick you could slam onto the table on Steam if you're like recommended graphics, integrated graphics. Come on, that's a fucking story that writes itself, bitch. I just feel like, or maybe I'm overthinking it. Maybe it's because we are just a 2D game with like no 3D math at all. We don't have like 3D matrix fucking rendering shit going on. Maybe I'm overthinking it. Maybe we don't have to be as efficient as I'm imagining and we still get integrated graphics anyway, you know? Use a standard union. Yeah, I've seen that suggested a few times, but isn't a standard union, isn't that just a vector standard pair? Oh my God, uninitialized value construct. Yeah, that's what I wanted, C++. Don't do it. Don't do it. Wait. Standard union. Yeah, it doesn't exist. Did you fuck with me? I think what you meant to say was standard variant, right? Map int object A. You can do A134 and it magically gets allocated. Standard map. Oh, are we just gonna end up doing a standard map like everybody else? So what? It's gonna be standard map, standard any, standard position. Oh, not standard position. Standard any. Standard any? No, this is wrong, right? A class qualified name. It'd be standard entity, right? Wait, what the fuck am I doing here? Hold on, I'm doing this wrong. You can tell I have very little experience with indexing and maps. Union declaration? What, like a pair? Optional sequence of any number of attributes. A name of a union that's being defined, optionally prepended by a nested name specifier. Explanation. The union is at least as big as necessary to hold the largest data member, but it's usually not larger. The other data members are intended to be allocated in the same bytes as part of the largest number. The details of that allocation are implementation defined, except that all non-static data members have the same address. It is undefined behavior to read from the member of the union that wasn't most recently written. That sounds like it's an undefined behavior kind of situation. So yeah, if you have a union of UN32TN, SC, 4 bytes, 4 bytes, 1 byte, the whole union occupies 4 bytes, initializes the first member, that is now the active member, and accessing the others is undefined. So I can't use a union. It would indeed save on space, but oh god, what's an example of using this? I'm trying to think of like when you would use this. Oh god, I can't even think of an example. Basically, it's an extremely efficient form of data storage for an entity of some kind. The problem is it doesn't fit our use case, because we could store like union for all of the information, every component we could have for an entity, right? Its position value, its Boolean values, int health, damage, all that stuff, right? And it really is efficient on space, right? Because it just takes the largest data set, usually takes the largest data value, and just that's the size of it. It's so beautiful for storage. Problem is, you can only read the most recently written. That's the issue. Beautiful construct doesn't fit our use case though, because I might need to like, okay, your health is now this, Mr. Entity. How much damage do you want to return in thorns? And I have to read something else, but that's undefined behavior. Union is a great way to practice debugging. How so? How would you practice debugging with it? I'm not licking my thing. I'm actually licking. You guys know I have a scar there? You can't see it very well because I have my little goatee there. Right there. There was a time when I was a kid that my 2 bottom middle teeth went through my lip. That's really gross, I'm sorry. Where it went through my lip and then went back in. So I have 2 little scars there. I was in I'm gonna say 2nd grade. We were playing on the teeter-totter, or as you may not know it as, the death trap. So what we do is, because we were stupid children and we live in a rural area, we don't play by the rules, we're rebels. Normal kids would like sit on one end of the teeter-totter, and then you would sit on the other, and you would kindly go back and forth in a very gentle rocking motion, okay? That's how normal kids play. We decided we're gonna be adventurous. So what we would do is one kid would sit on the end, and then everybody else, like 5 kids, would slam down on the other end as hard as you could, and the kid would just go flying. And it was pretty fun. All right, you got some sick air doing that. And yes, injuries happened. Now, you may think, Gary, you're a dumbass. You probably did that and got your face crushed in. No, I was walking by it happening when they slammed down on one end and some girl was on like the other, I forget who. Anyway, was it Aislinn? Oh my God, it's been so long. Anyway, so some girl was on the other end, so it went up really fast. I was walking by and it smacked me in the chin. Yes, it was a disaster. So I don't remember what happened. I don't remember it happening. I remember like walking by, and then the next thing I remember ever, and it's so weird how like I just have a gap there. The next thing I remember is walking toward the TA out there, the teacher's assistant, walking, and hand below my face and blood is just dripping onto it. And I'm like, I am gonna die. And of course I'm crying. I'm like, oh, I'm gonna die. And so my teacher, I remember the teacher's assistant, she's like, what happened? And I was like, the teeter totter, I was just walking by. And she was like, oh, we're gonna remove that thing. We ended up going to the emergency room, and chat, believe it or not, they put glue stick on me. Yeah, they put motherfucking, it wasn't Elmer's glue, but it was a glue stick little thing. He's like, hey, look at this. He's like, I was like, what the fuck? My mom thought we would need stitches, but no, my use case, because I only had my 2 bottom middle teeth go through my lip and then quickly come out. So what happened, it was like a hit. 2 bottom teeth went through, and then it went, ugh, and then it went out. So there you go. That's terrifying. So I'm fucking scared of teeter totters, chat. You'll never catch me near. If there's one in the playground, I'm like in the distance. I'm like that creeper. It's like, have fun, little Susie. I'm gonna stand over here. Fucking destroyed me. Holy shit. But yeah, they put glue stick on me. That was so weird. I was like, oh yeah, that's neat. You wore a helmet? Shoulda. Actually, no, it wouldn't have helped. Fuck helmets. It wouldn't have helped me at all. What the fuck? No. Yeah, so I have 2 little scars there. Chat, can I just say, god damn, my teeth look good on stream. I have good teeth. Now I want to brush them again. I didn't know that standard variants were type-safe unions. Yep. Well, that's our problem too. I don't know if we talked about it when it came to the ECS architecture talk at the beginning of the stream. We needed a container that was not a type-safe union. We have such a specific use case. Chat, how difficult would it be to write our own container? What would our own container need? Our own container, it wouldn't be that difficult for like our super specific use case, right? We need a container that does not, well, a vector would get moved around in memory if it grew of a sufficient size. So I guess what we could do, although it might be easier to just have the sparse container to handle IDs and like a real container to handle like the dense container to handle like the actual data. That's probably what we're gonna end up doing. But we could make our own container that could not move around in space so we could have pointers to it. It could, well, it would push back, so it would have dense values. It would be it all combined in one, right? It would be the sparse and the dense. It would take in the ID number. It would push back on a very small, like necessarily sized vector. We would have to handle memory management. It wouldn't be that difficult though. It's not like, oh, I need to iterate through it though. That wouldn't be that hard. It's not that hard to make your own container, right? Right? I bet we could do it. It would only take in standard any's. Ooh, no, it wouldn't. No, the standard any is for the type of components. Oh! Fuck, no, that's not what the answer is. How about a list base pointer, and for every component, class inherits a base, and then you can use virtual functions instead of switch statements? The problem there... Is there a problem there? I was about to say it was going to be a nightmare to implement, but you already accounted for that by getting rid of all the switch statements, right? It wouldn't be that bad. Yeah, it's probably just best to inherit in this case. Can we avoid inheritance? Guys, do you realize how big of a humble brag it would be to be like, oh yeah, I made a full-fledged video game engine, not a single case of inheritance. Oh my God, that'd be a fucking uppercut to the gut. Holy shit, put that in a goddamn interview. Be like, yeah, here you go, video game company. Here's my video game engine. Oh, by the way, there's not a single case of inheritance in the entire thing. It's extremely modular. Look at this. Oh my God. The dick size I could fucking... The girth. Standard det guarantees pointers reference to elements don't get invalidated and is fast at inserting at ends, but is slightly slower at indexing than a vector. that's an incomplete understanding of a deck, right? Because a deck has fast access at the very beginning and the very end of the vector of the container, right? That's what a deck is for, and it is like such a rare container to need, and it has the same problem as well, oh my god, are we using decks? Oh my god, that'd be so cool. Wait, can somebody explain to me why my standard any object is a 64-byte object, but my standard deck is a 40-byte container? Is this like Visual Studio fuckery or like what? What's going on with this memory? Although to be fair, a map is 24 bytes. Oh, maybe it's just it's just the size of the actual container object. Okay, I'm dumb, sorry. Okay, Jesus. Fucking need to think here. Not easily? I mean, a deck internally is basically a list of vectors, kind of like the rope container that never got standardized. Wouldn't it be better to use a queue? I take Code Toil's advice pretty heavily. I mean, he always seems to know what he's talking about. What's a queue? I've honest to God never used a standard queue before, so we're gonna look it up together because that's what I do. All right, what's a C? Bing? Get the fuck out of here, Bing! Holy shit! Not based. Okay, standard queue, go. Standard queue is a container adapter, container adapter that gives the functionality of a queue, specifically FIFO, first in, first out data structure. Class T and a container deck. That's cool. So its class container is equal to standard deck type T. Okay. The class template acts as a wrapper to the underlying container. Only a specific set of functions is provided. The queue pushes the elements on the back of the underlying container and pops them in the front. We're not really going to be using that though, right? I wouldn't say this is a use case for queues. Yeah, because, well, think about it this way. We need, okay, let's list out our requirements, okay? Maybe you guys can help me out. We have spent 2 days on these fucking containers, so we might just have to make our own, but this is my use case, okay? Let's get out, what are my requirements? I am the client, you guys are the professional, my consultants, okay? List the container that meets these qualifications, okay? We need a dynamically sized container that when I point to it, the pointer values never get invalidated by any resizing of the thing, so no vector. This container must also be fast to iterate through because we're going to be iterating it constantly. And it's going to be serving as, it must be able to be store a variety of object types. So float values, integers, fucking custom objects, anything that's copy... Is it copy convertible? I forget the term. Copy, maybe list it here. Copy type, whatever. It's copyable item. I don't know what other requirements we have, but I don't know if that's copy constructible. Thank you, Jesus. I'm so happy there are people who program a lot more than me here. But yeah, I don't know if there's, hold on, containers library. What's here? Array, no, because we want dynamically sized. Vector, no, because we're gonna have pointers to it, and when it gets resized, it might be moved in memory in order to make size. In place vector, C++ 26. What? Static and dynamically resizable contiguous array? Wait, in place vector? What? In place vector. Okay. This paper proposes a modernized boost static vector T capacity that is a dynamically resizable vector with compile time fixed capacity and contiguous embedded storage in which the elements are stored within the vector object itself. Its API closely resembles that of a vector. It's a contiguous container with 0-1 insertion and removal of elements at the end, and worst case O size, insertion and removal otherwise. Like standard vector, the elements are initialized on insertion and destroyed on removal. For trivial value types, the vector is fully reusable inside of context expression functions. Interesting. The in-place vector is useful when memory allocation is not possible, e.g. embedded environments without a free store where only a stack and the static memory segments are available. Memory allocation imposes an unacceptable for performance penalty with respect to latency. Sorry, I don't have water near me. Allocation of objects with complex lifetimes in the static memory segment is required. Standard array is not an option, e.g. if non-default constructible objects must be stored. A dynamically resizable array is required within these functions, and storage look interesting. I didn't even know in-place vectors were coming, but there you go. Give it 2 years. I only just got accepted to the standard, or it only just got accepted. Interesting. Yeah, I never even heard of it before. We have a deck, a forward list, a singly linked list, and we have a list. Let's look at the forward list here. What's this? Forward list is a container that supports fast insertion and removal of elements from anywhere in the container. Fast random access is not supported, which is fine because nothing's going to be random, I think. It is implemented as a singly linked list. Compared to standard list, this container provides more space-efficient storage when bind. Oh, is this a list without the pointer values? Is that all this is? Allocator. Adding, removing does not... adding, removing elements within the list or across several lists does not invalidate the iterators currently referring to other elements in the list. However, an iterator or reference referring to an element is invalidated when the corresponding element is removed. Oh, kind of based. Standard forward list meets the requirements of container except the size member function and that operator equals complexity is always linear. Maybe. I think we are maybe going to use a list. Forward list just doesn't have R begin. Ooh, that's bad. That's actually not good. We need R begin because we're going to iterate through the entire container constantly. Associative containers, a set. Okay, somebody said scroll down. Oh, shit. Okay, oh, kind of base. What's this? Member function table. Oh God, how do I zoom in and not get my fat head in the way? There we go. Okay, member function table. We have iterators. Oh, okay. String, array, vector, element access, capacity, modifiers, list operations, bucket and hash, lookup, observers, allocators, adapters, non-member function. Operators and shit. Okay, let's pass on that for now. Set, multi-set, multi-map. Okay, associative containers. Associative containers implement sorted data structures that can quickly be searched. Oh, log n complexity. So we have a set, a collection of unique keys sorted by keys. Just so I understand it completely, a key would be that void pointer value I was talking about. That is a key, right? No. Maybe. I don't know. Maybe? Map. A collection of key value pairs sorted by keys. Keys are unique. Oh God, we're gonna end up using a map, aren't we? Key is the identifier, so the entity ID number. Oh, the MID number. Oh, you're right. So we have a map, right? This map is not going to contain standard any. It's going to be MID. No, this doesn't go here though. It would be an ID. It'd be an int. Then this is a standard any. Is that how that map would be phrased? Yes, that is a map. So let me understand this correctly and how we're going to use it, because I think we're probably going to end up with this. So this is what M components is. M components is a map. The map contains an integer value. No, it wouldn't go here though, right? Would it go outside of the entity? Is every entity going to have its own map? Is that necessary? In any case, we have a map and it's, yeah, no, this isn't it. It doesn't go here. I know it doesn't fucking go here. I don't even know why I put this here. In fact, what it should be, copy, motherfucking, it replaces positions. That's what you're telling me. Standard map, oops, standard map, int, comma, standard any. No, it wouldn't be a standard any. It would be, no, it would be a standard any. Fuck. Standard any. Component map. And then on this component map, you would have standard vector position. And then this would be on the map. Is that how we're framing this? Ideally, the entity wouldn't know about components at all. Yeah, well, I agree. The only thing it would have is some bit set saying true or false if it even has a component, because we're iterating through that a lot. This is just a bit set that's like true or false if it even has it. And then a standard whatever, a vector, an array, whatever it's gonna be. Well, actually, no, that is kind of based. We would do a standard array, which contains an any and a size, which is number of components. Because it would never be bigger than that, right? You can't have more components than there are number of components in the program, but you can't do that because it should be under the data namespace. Number of components. I could do that. That's kind of cool. It would be a big object though. This is like the biggest object in there because every standard any is like 64 bits. And if we have like 500 components, that might be a problem, but you get the idea. 50,000 standard any's take up 3 megabytes. We're being efficient about it. Okay, we're not gonna have 50,000. Oh no, it would be 50,000. It'd be worse than that. It'd be number of components times number of entities size array. Okay, that's a bad implementation, but you guys get the idea. Bytes or bits? It would be every standard any is 64 bytes. Pretty big. Whereas a bit set is number of components bits wide, which in this case would be 13. Maybe up to, if like I'm imagining by the end game we're gonna have like 500 components because we're gonna have like fireball sound effect, frostbolt sound effect. I don't even know if we're gonna have fireball, but like attack sound effect 1, attack sound effect 2. I would imagine each of those would be a separate component, right? Is it? Or would it reference some table of sounds? And just having the component would be, I don't know. But in any case, we're gonna have a lot of components. You could use a multi-map for this use case. Are you sure you want to use a standard any? It's 64 bytes long per object. Yeah. There's no other, I don't know what else to use. Like, how else do you reference? Like, like, obviously we're not going to use this implementation, but that line, how do you have a container that has the values of every component if it's a variety of different types and objects and everything? I mean, void pointer is our next option, but like, it's undefined behavior to dereference a void pointer in C++ anyway, right? Dynamic polymorphism. So virtual. Dynamic polymorphism. So you're saying like, obviously it's not the implementation you're talking about, but you're saying like int x equals 5, x equals 5.0, type x, right? So you're saying that where it's going to end up being a float instead of an int, that's dynamic polymorphism, right? Where it's automatically casting the object to a different type and dynamically handling memory. Is that what you're talking about? Object-oriented programming. Blech! Listen, fucking, that was a terrible clap. Listen, we're not object-oriented cucks here, okay? We are ECS chads, okay? Get that inheritance talk out of my fucking face. It's trash, all right? We are transcending with C++ video game engine programming with no inheritance, okay? If I hear the I word one more time, I'm gonna start being not nice, all right? I say that jokingly. Have a base type and inheritance? No, we're not doing that. We gotta be based, all right? My goal, I want the UI to be able to shoot a bullet at the drop of a hat by just adding a couple of components, okay? That's my goal. Am I ever gonna need that? No. Do I want a game so modular that I can do that? Yes. You're making this so much more difficult than it has to be? Yes, because I'm learning it, and by exploring our options now, I don't learn bad habits later. You have to understand, chat, we've already made, like, almost one video game engine, right? We've already been through that journey. That was with object-oriented programming. And I immediately saw our own limitations before my eyes when I tried to add animations to that shit, and it's fucking difficult when like I wanted to grab like, oh, I loved what I did for the card pop-up. Let me try to add that over here. And it's like, oh my God, I have to copy paste it. I want ECS to work, okay? Each component type should inherit from a base component class. Each component type should inherit from a base component class. No. I don't think it should. I do think that every component should be put on a vector. No, it doesn't even need to do that because we have like our a little enumerator here, so that's all easily accounted for, right? Every individual instance of these are going on a vector. What would be the benefit of that? Okay, so we have a standard map where the int is going to be the MID of any given entity. That's the key. And then this standard any is any given value of any of these structs above it. Could be a color, float, floating point value, int, whatever, right? That is what this any can be. And we're going to call it component map. I just misunderstood what I just said. Ignore everything I just said. The standard any does not stand for any of these components. The standard any is the position vector and the damage vector and the health vector. Every component's going to have a vector to it. No, that's wrong. Wait, what the fuck? Hold on, what's the order of operations here? So if I have an entity and it holds a pointer value to, which is like a reference, like go to this place in memory to like find this information about what I have, right? For this component, like a position, XY value, right? This floating point value that it's pointing to, where is it actually located? Is it on the map? But it's on the vector. That's where it's located. It's on this vector. That's what it's. Is it? I thought it would be on the vector and then the vectors would go in the map. Are you saying we need to have different maps for everything? So this is actually positions? Where it's not a standard any anymore, it's a C positions. Oh, we don't need standard any here. Standard any is for the fucking array in the entity vector. Glum is following. Thank you. Welcome to our learning experience. Okay. Okay. I'm an idiot. We don't need a standard any in the map because every component, it's going to have its own map, right? So paste, 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 right? So everything is going to have its own. So this is C velocity. We're going to call this velocities. I know that's bad grammar, but we'll be consistent here. Render rect, so C bound rect. Yeah, I like this. All right, okay, I dig it. So this is bounding rects. Yeah, and then every map is associated with, oh my God, this solves all of our problems. Holy shit. It even solves. Wait, does it solve the MID limit problem where if it has an ID of like 50,000, does that fuck up memory? I have so little experience in map implementation. It's kind of embarrassing. If I give it a value of like 50,000, is it gonna need 50,000 instances of bounding recs in order to like reach that value? Chat, I am aware this is bad grammar, okay? Just give me a break. Oops. Gary, don't repeat yourself. Yeah, well, Jesus. No. Wait, what's up? I know I just asked a question that you gave a very succinct answer to. I don't understand what the question I asked was. Wait, did I ask what? Okay. I think I asked, does a standard map, if you give it an integer value of 50,000, does it reserve 50,000 instances of C positions? You're saying no. A map is implemented usually as a red-black tree. Dude, I'm on like week 3 of intro to computer science in my university. You think I know what the fuck a red-black tree is? I didn't even know I have trees of colors. Did you guys make that shit up? Did you guys look at a checkerboard and you was like, those are gonna be the colors of our fucking trees? Jesus, trees are green and brown, chat. Oh, that question is no. Okay. Cool. Excellent. So you're saying I could give this integer values of 3, 50,000, 1,200, and this map will only reserve enough memory in my system for 3 C position values. Okay, that is actually incredible, and I'm so happy they invented something like that. It solves all of our problems. Okay, beautiful. Oh my God. We actually can start implementing things. Wait, we already did C damage value. C damage type fire. Damage type fires. Do Boolean values need a map? I mean, I guess they do. It just feels very... That's the only thing I don't like about this, is it feels really weird how we're implementing Boolean values. That's the only thing I don't... It's the only thing I don't really jive with, you know? By the way, I would consider these like the basic things to test on Saturday if these are all implemented like in a decent way. Is controllables. I feel like there must be like a Python way to do this easily. Is damage. The problem is I'm worried there's going to be a lot of tech debt in terms of how we're implementing this. Like if we want to add a new component. because I need to add a new map. I need to add it to the enumerated value. I need to add it to like a bunch of things, you know? Okay, is shooting, is moving. All right. Is movings. Okay, so now we have our entire map of everything. Do I put this all in a fucking array? No. Where's my music? Hello? Star Guardian, be the rescue. No, it might take more than 3, but it's not as much as the highest int you have. Depends on implementation. We'll see. We'll implement it our way and we'll see how bad it is. Okay, cool, perfect. All right. Does this all need to go on an array? Probably not. I don't think there's going to be any system in the entire game that's going to iterate through every single component. Not even every component. It's going to iterate through every component vector for every entity in the entire game. No system will ever do that. So I think we're fine. Okay, cool. Now let's go back to our entity thing here. So this is a bad implementation. We need a way to store M components, which is just void pointers. So now we're back to the standard any problem, which means I need a standard vector for a standard any for M components. What? Why are you expecting another arrow? Oh, there we go. Save it. Does everything compile? Oh my God, compile with no warnings. Oh, chat, call me a programming god. There wouldn't be this much tech debt if you had used OOP in defining your components. Ha! We're not using no inheritance shit here, boys. We're going pure ECS. Okay. I think this is what we do. And then we add to this every time we want to reference something. Why do you store components inside of entity? I don't. It's a pointer. A standard any is a glorified void pointer. That's all it is. We are not going to use void pointer because we need to dereference the value to kind of fuck around with it, because we're going to be changing values. And dereference in C++, not C, C++, dereferencing a void pointer is considered, as far as I know, undefined behavior, because a void pointer can point to a place in memory, but it doesn't actually know what it is. It doesn't make it an integer, so you have to static cast it, which works in C, but in C++, I think you actually just get an error. So instead of a void pointer, we use a standard any, which is a void pointer, but it's defined void pointers. That's really all it is. That's why it's 64 bytes though, because you can dereference the value. It knows what it is. That's kind of thing, right? And it's beautiful for our use case because of how modular the game is going to be. It truly can be like a million different values very quickly. So that's kind of why we're doing it. Are you sure standard any is a pointer or reference? It's intended to be a pointer. Am I wrong in that implementation? I believe I am correct. Standard any is one of the newest features that provides a type-safe container to store a single value of any type. In layman's terms, it is a container which allows one to store any value in it without worrying about type safety. It acts as an extension to C++ by mimicking behavior considered the object type or void pointer type in C language. It's a pointer. Although this is back when it was, yeah. So using namespace standard any value equals 42. Any cast int value, yeah. Any cast is part of the standard feature of an any. Value equals hello world. Value, const character pointer value. So yeah, you can just change it to anything. A string, a float, it doesn't matter. custom objects. That's why an any is so big, because it has to account for the fact you could have a 64 byte value. It's intended to be anything, maybe not a reference, any value type. The type safety is actually coming from checking RTTI. I don't know what you mean by that. In any case, oh, no. Do I need to worry about like shared pointers or standard pointers yet? No. Or unique pointers? No. Because, hold on. Now we can do this. Okay, that's done. Now we can do this. So data positions point. This is wrong. This doesn't work. So now we have data positions, which is now a 2-map process. So I don't know the syntax for maps here. Is it bracket MID? So that's the key dot point is equal to 0, 0. Is that the syntax? Oh, it is. Okay. That was easy. Oh, I got it. Yeah. Anyway, so that's why standard any is just really good for our use case, I think. So yeah, we have a data positions point equals 0. Now, obviously, we have to account for the fact that we have a million different maps now going on. So this isn't just points we're adding, but still. So next is standard any pointer is equal to the referenced value of data positions point, which is this. So what we should say, no, this is right. I have to do this in this order, right? Oh no, wait, no, this is bad. Wait, entity dot. This needs to be entity.mid, doesn't it? That's what I should do. And then this is entity.mid. And then entity dot m components bracket dot pushback parentheses pointer. Is this how we should do this? Those 3 lines? I can't see any obvious issue with this. But I've also never done this implementation before. Does this need to be a pointer? No, it's the equivalent of a void pointer. I don't need to specify like any pointer. Yeah, that doesn't work. Standard any is not a pointer. By default? Oh shit, no, I'm not referencing dot point. I'm referencing that spot. No, I am referencing dot point. Yes, I am referencing that point. True. So it needs to be a pointer though, doesn't it? Yeah, because this, all this is doing is just making this point, the actual point value, this. It's making it 0, 0. And then we're just pushing back on a vector that contains an any. So it's just a really inefficient way of storing things. Standard any can store a pointer. Well, if I wanted to point to just a place in memory. Wait. Hold on, maybe I'm misunderstanding. I thought So you have objects, references, and pointers, right? So the object exists in some space in memory. A reference is just saying that whatever is in that point of memory is that value, right? So if int x equals 5, the object in memory, and then you have, the object value x is equal to the value of 5, then you can reference x in the future, and what you're doing is not referencing the object value x, but where it is in memory, whatever number is there, perfect, right? I think. And then a pointer is a value, like pointer y is equal to the referenced value of x. Then whenever that memory spot changes value, everything changes value. But if the pointer y is equal to the x value, not the referenced x value, then x can, or that memory spot can change value, but the pointer never changes? Is that what's going on? A reference is a non-null pointer. A pointer is a memory address. So this does need to be a pointer, right? So this is an any pointer. That is what I want. There is no suitable conversion from floating point to a standard any. Why? I presume what code paradise means is that the value is stored in the standard any instead of a standard any being a pointer itself, right? Oh, shit. I see what you're saying. So what we should say here is float pointer is equal to, SDL float. What the fuck is the value? Standard f point, Jesus. Standard f point pointer is equal to the referenced value of data positions. And then we're going to push back. There we go. That's how I do that, right? Maybe make a shared pointer to the standard any. Yes, I like your thinking. This is a standard shared pointer. Should it be a shared pointer and not a unique pointer? No, but we're gonna do it anyway. Oops, shared pointer. I understand there's much more better implementations to this. Oh my God, do these all need to be shared pointers? Oh my God. It totally does, doesn't it? Wait, no it doesn't. This doesn't need to be here. This. Oh, yes it does. Does this work? Oh God. Oh. The reason standard any is equivalent to void pointer is that void pointer can be any type. Yeah. Work awaits tomorrow. Catch you next time and good luck with the project. Thank you, Cable. I see you lurking there in YouTube chat. I appreciate it. Man, chat, I am having a bad hair day today. Holy shit. Maybe make a shared pointer to the standard any. I think that is correct. But I think I'm doing something wrong here. So this should be a shared pointer, right? I think so. This is correct. Now I need to point to that spot. So this is the first problem. Failed deduction. Failed deduction. But void pointer is a pointer to any type, while void any standard any contains any type inside of itself, right? Hold on 1 second. Let's just ignore the shared thing for a second. Yeah, ignore the shared thing for a second. Let's just talk about this. Okay, hold on. Redo. Okay. So, this works as it is right now with no type safety, not type safety, with no memory safety whatsoever, okay? Yes, by use of type erasure. Same use case, different implementation. Yeah. So this is without any sort of memory safety. With that in mind, this is not complete. All right, very far from it. Whenever we want to add a component and it passes whatever minimum error checking we have right now, we access in the data namespace the positions map with the key of this ID of whatever entity we give it, right? And then that point is just that position value, but it can be any map we point to, right? Then we give it a value, which is probably zero, but we should be able to easily change that. Then we create a pointer. This pointer is going to be of type whatever component we're going to give it, right? Then we're going to access the data by reference, the data namespace positions map point that we just created the value for. This is a pointer to that memory address. Then we make a standard any, which is literally anything. It's just a void pointer, a glorified void pointer. And this void pointer is equal to that value. Then, this standard any is now this floating point value, right? Then we push back on M components, this entities, M components. This should be entity.m components. Push back on that, and then we flip the bit set, right? So without any type safety, if I now ever need to access that, that's how we would access that. Well, not a void pointer, but a wrapper. Yeah, basically. Yes. Okay. Now I understand this is like not even 30% done. And if we submitted this to a much better programmer, they'd be like, what the fuck? This is so unsafe. There's a memory leak. In MVSVC, standard any is implemented as a union. Wow. You said that out of spite, didn't you? You're like, I'm gonna tell this motherfucker what he should have done 2 hours ago was use a goddamn standard union. Is it really? I guess it is. No, it is, because the value you're changing last is whatever the value of the any is. Oh, that's kind of funny. Yeah, I guess you're right. I guess it would be a union, huh? Because if it's a union, it can be 64 bytes. Even if you make it a string or an int or a float, it's always the size of the biggest value, which I guess in this case, 64 bytes would be like what? Like a long int? How long is a long int? Oh my God, is it really not going to tell me? Really? Local variable long x. Oh, come on. God damn it. Really? I think it's 64 bytes, but now I'm curious. Long int is up to 2 to the power of 31, which is 2 to the power of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Overflow. 64 bits. Oh, no, that was bad. Wait, no, I'm not squaring it again and again and again. I was doubling it. I'm not even doubling it. Okay, that was bad. Don't do that. So what it should be is 2 to the power of 64, right? So 2, which is squared, so 2, 16. So now it's 2 to the power of 4, 2 to the power of 16, 2 to the power of 32, 2 to the power of 64. So it can contain up to 4.2 billion, right? Right? Did I do that right? 4.2 billion? Or no, that's a... Wait. No, that's an unsigned int. 32, 64. Wait, am I dumb? Does a standard any hold 64 bytes or 64 bits? Oh, it's bytes. Oh my God. Oh, Jesus Christ. Okay. Holy shit. A long int is 64 bytes. Okay, that's why I was a dumbass. Okay. 64 bytes is like, what? 256 bits? So it would need to be squared. That is the size of a long int. No? Listen, I'm a computer science student 3 weeks into his fucking course. Are you telling me that's wrong? Do I not press the squared button fucking that many times? I think this is it, right? How long? We could just Google this. Get out of that. Okay. Long int. All right, tell me about it. A long int typically occupies 4 bytes, which means I can remember that. A long int usually occupies 8 bytes, doubling the size of the long int. It can represent values from 2 to the negative 2 to the power of 63, 2 to the power of 63 minus 1, which is how big? 9.2237, scientific notation, 10 to the power of 18. 9 quintillion. Oh. Oh. Wow, that's a really big number. So I guess my question is, 512 bits or 64 bytes, since a byte is 8 bits. I thought a byte was 4 bits. Am I dumb? Am I stupid? Am I the only one who thought a byte was 4 bits? Yeah, a byte represents 16 bits, or 16 possible combinations, right? Am I dumb? No, I am dumb. That's not true. It's 2 to the power of 3. 2, 4, 8, 16. 2 to the power of 4. A byte is 255 possible values. Yeah, because it's 2 to the power of 8, right? No, I'm right. Yeah, I'm right. Think. What is a byte but 8 bits? Or sorry, 4 bits. Fuck. God damn it. No, wait. 1 byte is 8 bits, an octet is 8 bits? Oh my God. Am I gonna fail this fucking university course? I thought a byte was 4 bits. I thought every 4-bit like chunk of like 4 numbers, 0000, that was a byte. Wait, a byte is 8 bits? So an integer is 2 bytes, not 4 bytes. And a float is 4 bytes and not 8 bytes? You can have 7-bit bytes. Listen, let's not get to the exceptions right now. I'm getting my mind blown at integer values, okay? You need to find a very weird hardware to have a 4 bits byte. Oh. Okay. I got you. 1 nibble is 4 bits. 1 byte is 4. Cute. Okay. Well, shit. You learn something every day. So, chat, what does standard any have to contain for it to hold 64 fucking bytes? That is a number so indescribably large that it's not a number anymore. What standard library? Now I'm super curious. What does a standard any? It's a union, right? So what is the biggest size of it? Chat, why am I not just using a union? What is like the biggest size? Exception thrown by the value returning forms of any cast on a type mismatch. Oh. Type safe access to the contained object. Type safe access to the contained object. I don't need that right now, but I will need it whenever we try to change any values. Standard swap has value type emplace. Wait, I can emplace with a standard any? Oh, I guess you have to be able to, huh? Standard any can do heap allocations, so it can be more than 64 bytes. Oh, shit. Struct big storage, pads so that pointer and RTTI might share type data's cache line, unsigned character padding, any small size point, void. This is the biggest object in standard any. Holy shit! Chat, is there a way? This might be stupid. Is there a way to have a standard any only be the size of our biggest object? Think of the space savings we could have, chat. Think of how much space. That's gonna be like a third of a kilobyte every entity. Chat, if we have 10,000 entities, that's like 3 megabytes of memory we're gonna save. Is 3 megabytes of memory worth it? I don't know, probably not. Think of who can spare 3 megabytes of RAM in 2024, chat. Okay, maybe we're a little too hyper focused on the minutia. All right. We're gonna end stream before I go crazy. This is what we're gonna do tomorrow. Though, stick around, okay? I'm gonna stream tomorrow, don't worry, okay? This is what we're gonna do. We're gonna make this function actually have proper error reporting, and we're gonna give it shared pointer. We're gonna do RAII on it. We can't just have raw ass fucking no condom C-based pointers in my C++ program, okay? We also need to add a remove component method for the entity object. And then after that, we're probably gonna make an entity manager to make entities, which would give them all unique IDs. So when we call the map, here, data positions, whenever we call that map, we have a way to like give it a unique ID, right? That's important. If we want to get really fancy, the entity manager, when it culls, because it will also be responsible for culling these entities, we can also have it where when an entity is culled, its unique ID frees up. Will that ever matter? Does that ever matter? Actually, it kind of does matter. Because if an entity shares an ID with a previous entity, and it would free up some memory. I don't know. It depends on how efficient we want to be with our time. In any case, we're going to have an entity manager tomorrow, along with a remove component, along with fixing the add component. And then from there, I don't know what else we're doing from there. Are we adding like render stuff? I think at that point, we're just adding rendering and we can have something prototype tomorrow. Because we have our entity object, and there you go. That's our player character. Long int equals 64 bits going. Hold on, you say that, but when I highlight standard any here, it says size 64 bytes. Alignment 8-bit bytes. Feels pretty fucking big. Although to be fair, this floating point value is 8 bytes. This int is not telling me. I don't know. It is big. Oh God. You would want to free up IDs. Standard any has more than a pointer in it. Standard any is not a long one. Yeah. Standard any has a lot going on. A void pointer has nothing going on in it, and it's very unsafe, but that's what standard any's for. That's pretty cool. I learned a lot today, chat. I learned a lot about like containers. This is a container stream. So I'm titled the YouTube thing. We just learned about containers for 2 hours. Okay. Tomorrow, finish this, add a remove component, which is just the opposite of this. Because this I feel super weird about here. What else? We need an entity manager that needs to create and destroy entities where we free up the unique ID number and then account for that. But then after that, we are ready to make the super basic game loop where we're going to be testing out movement, which is trivial with SDL. I mean, SDL has like all the input stuff already done for us. So sweet. All right, we got a plan. Tomorrow we're prototyping. We have our entity stuff kind of done. And holy shit, that looks ugly. But that's the plan. All right, back, save. Get out of that. Come here, chat. Don't look at that background. That's lewd. All right, chat, remember I'm a VTuber, okay? We're gonna be back tomorrow. We're gonna be doing more programming. It's gonna be exciting. I'm lagging like crazy. I don't know why. Come here, give me a lick. Tasty. I'll see you guys tomorrow. Goodbye.